All right, chemistry class. So there's one more short video for today, and we're going to refresh your memory on how you diagram an atom. This involves a lot of important concepts, including knowing how many orbitals it has, how many protons, neutrons, electrons, and particularly how many valence electrons it has. So let's go ahead and do one that was that's in the third row, silicon. So that'll give you a kind of a good example of any atom. All right, so the first thing we need to do is you write your scoreboard out. And the first thing we're going to find out or determine is the number of protons. All right, so how do we do that? Well, silicon has an atomic number of 14. And you can see it's right there in the middle, down in the third row there. And so it has 14 protons. And since an atom is born electrically neutral, it's also going to have 14 electrons. 14 positive charges, 14 negative charges. So we can go ahead, here's the number right there, that's the atomic number, also called the Z number. And now we can go ahead and put those 14 protons and electrons in the scoreboard. We can go ahead and put the 14 protons in the nucleus as well. So there the nucleus is holding the 14 protons. Next, the number of neutrons. So what we have to do is see if you can remember how to do this, but you take the atomic mass. Oh, and I forgot the electrons. We're going to put those off to the side, and they're going to take a long time to come in, so I'm just going to do that. There you go. There you got 14 electrons there. Okay, now you take the atomic mass, which is the number at the bottom. It tells you two things. It tells you, well, first of all, it tells you how much the atom weighs, what its mass is. We'll move to that slide. So now we round the atomic mass to the nearest whole number. So your typical silicon atom is going to have a mass of 28. And that means since each proton and each neutron has an atomic mass of 1 atomic mass unit, if the atomic mass of silicon is 28 atomic mass units, then it must have a total of 28 protons and 28 neutrons. We don't count electrons, they're very light and they're not counted in this calculation. All right, so now we're going to go on and we're going to figure out how many neutrons that we have. So we're going to do that little subtraction problem. So we can now calculate the number of neutrons by subtracting the atomic number from the atomic mass. So the atomic mass, 28, that tells you the number of protons and neutrons. We already know that the atomic number is the number of protons. So if we take protons and neutrons and subtract out the protons, get rid of the protons, we know we'll only have the number of neutrons left. And so in this case, that's going to be 14. So we can go ahead and fill in our scoreboard. And we can go ahead and put the 14 in the nucleus as well. So our nucleus is taken care of. 14 protons, 14 neutrons. Now we're ready to go on, and we're going to figure out how many orbitals silicon has. So the rule for that is simply because silicon is in the third period row, again, a row is called a period in chemistry, it has 3 orbitals. So everything you see there in green is in the third row, and all of those elements, the atoms of all of those elements will have 3 orbitals. Again, orbitals are energy levels. They're different levels that the electrons are allowed to fly in. You can think of them like train tracks. Train can't run in between the train tracks. It has to run on one set of tracks or on another set of tracks. So that's what's going on with the electrons here. So silicon has 3 orbitals, so we can go ahead and we can place those. Actually, we'll fill in our scoreboard first. And now we can go ahead and place, there's the first orbital, there's the second orbital, and there's the third orbital. Now we're ready to go on, and we can do this one of two ways. We can either figure out the number of valence electrons, or we can go ahead and place the electrons. And so the first thing we're going to do is go ahead and just place the electrons. So now we place the electrons. The first orbital gets 2 electrons. And then it's going to be full. So there's the no vacancy sign. You can't put any more electrons. It's too small. They're too close to the nucleus, and you can't fit any more electrons into that closest orbital to the nucleus. And so it's full. And we put them side by side. Some books don't do that. I do it because I want to show that they're paired up. That means they cannot bond with any other electrons from, say, some other atom. Okay, now the second orbital gets 8 electrons, and then it's full. Now the way I place them, I do this because when we do Lewis dot diagrams, you may remember we did those, and we're going to review them again this week, this is the way you would go ahead and place them around a Lewis dot diagram. So now the fifth one pairs up with the first one, and then the sixth one pairs up with the second one, pairs up with the seventh one, and the last one pairs up with the fourth one. Okay, so they're all paired. So you have 8 electrons. Since you have 8 elements in the third row, in the second row, that second orbital can hold 8 electrons. It's just however many elements are in that row, that's how many electrons that orbital can hold. Finally, we have 4 electrons left. By the way, we now have a no vacancy in the second orbital. You can't fit any more than 8 in the second orbital. And now the final 4 electrons go in the outer orbital and they spread out, just like we did in the second orbital for the first 4. So there's the first one, there's the second one, and there's the third one, and there's the fourth one. And so now we've placed all of our electrons. So now, though, we have to ask how many valence electrons do we have? Well, we can see by looking at the diagram we have 4. But what if you wanted to know that without having to draw this whole diagram? Because sometimes that's all you want to know is how many valence electrons an atom has. They're the ones that get involved in chemical bonding. So we know that silicon has 4 valence electrons because it's the 4th element in its row. So as we watch the numbers come across, sodium is 1, and magnesium is 2, aluminum is going to be 3, and finally silicon is the 4th element in its row. And therefore silicon has 4 valence electrons. And there it is. And so that's it for silicon. Okay, so I gave you a couple of these to do on the assignment, and just use this as an example, and that will be your assignment for today. Have a good day.